All right, cool. Okay, so yeah, the basic idea of this is to actually recognize the image on the top. These are two eyes, basically, on the top and bottom for player one and player two. And player one is going to be controlled by NuPIC, but actually, I recognize the image with a pre-trained neural net that does image classification. It did really well on ImageNet 10,000 category contest. So it basically takes these two eyes on top and transforms them into 1,000 numbers that represent features that a team at Berkeley was able to say whether something had a cat or a type of bird or some bookcase or whatever category in this ImageNet data set. And these features actually are generalizable, so other teams have just used this pre-trained neural net and won other competitions and been able to recognize images. So it works on things other than ImageNet, so I thought it might work on this game. And I basically trained, let's see. So I did like a random bot on top, and I played against it. And I took the times where the random bot was successful in hitting me with a shot, and I multiplied that experience by 10 and ran that through NuPIC. And anytime that the bot was shot, I took that out. So I only trained it on the times it was successful. And like Matt, unfortunately, I wasn't able to like do something super intelligent here with the bot. Well, the bot isn't intelligent. Sorry. But yeah, let me just show you how it works. Okay, so that just loaded up NuPIC, and then so this on the bottom here is NuPIC, and it's just an HTTP server that accepts the input and the features of the image. And then this is the pre-trained neural net. And okay, so the top guy is going to start. He likes to move to the right. That's basically what he learned. So. Oh, thanks. Okay, so I'm controlling the guy. And now he's kind of settled on, I'm just going to not move to the right. So he either decides to move to the right really fast the whole time or just stay still, depending on what he sees, which is kind of interesting. So I can actually control everything except the horizontal direction on this top bot. So I can actually like go towards this wall here. And if you look on the bottom at the features, this number here is coming from those 1,000 numbers, and NuPIC has decided that one of the 1,000 features is important to determine whether I basically survive or not. And you can see it zeroes out there if I look at the wall. So it is actually recognizing the image and like giving a meaningful number out.
What does that mean when it zeroes out? That it's not survivable?
So a zero feature is just, it's an input to SVM in the image classification algorithm. It's just a high-level feature. So it could mean like a cat, if it's image, the 500th feature. In this case, feature 189 was the one it thought was the one NuPIC thought was important to determine which direction to move next. Yeah.
You swarm to get 189. Does it give you a range for each category? I mean, to know from the classification, does it? Do you know if like the range of which category it falls in?
I don't actually. I don't. It looks like 0 to 10 here, but I didn't normalize the numbers going into NuPIC. I figured NuPIC would choose encoders via the swarming process that normalized it.
I
just got several questions. I want to make sure I understand what's going on here. So you've taken up, you have 1,000 parameters coming out of this vision system.
Mm-hmm.
You swarmed, you picked one. You're now feeding that as a series of data points into NuPIC.
Mm-hmm.
You train it on good ones, good sequences.
Mm-hmm.
How often is that sampled? I mean,
10 times per second.
10 times per second. You're looking at a sequence of these things 10 times every 10th of a second. That's pretty fast.
Mm-hmm.
We don't, and then you're trying to use that as a prediction of that. I'm confused. So you feed that number into NuPIC.
Yep.
It's learning those sequences. What do you do with that then?
So I fed that in addition to the horizontal movement number. So that's this second number here, 0.
Yeah.
So it uses what it moved previously, and then this feature to determine what it should move next. What
so
move
you
should
make
it
a
make.
prediction, and then you feed that into to drive the behavior. Is that
Yeah,
right?
exactly. Yeah.
But we really have no idea what this visual feature is, right? It's
Right.
just some cat thing.
Yeah.
Got it. But since Swarm picked it, we would assume that it has some correlation to the success of the.
Right.
Interesting.
Right, and it was 10,000 rows that I trained on.
And I can't. And did you? Can you explain qualitatively? I kind of didn't understand.
Mm-hmm.
Is it helping or not, or doing anything? Do you know what's going? I mean, it's moving to the right. You're saying.
Right.
Is that good?
I don't know. Apparently, when it was successful before, at least if I did this right, it moved to the right and avoid being shot and landed shots.
But we don't have a control experiment going on here, so we know whether you're living longer before than.
Right.
Okay.
Right.
Just trust in go with the flow. So got it. Thanks.
Yeah. So I guess the plan would be to play these against each other. Actually, Subutai was talking with me about this, and have it evolve to pick the winners, basically.
Yeah, just so we were talking earlier. I think this idea, as well as like the Pong, the puck idea, is really interesting because essentially just by watching you play, it's kind of learning how to play better and better.
Mm-hmm.
So I think the core of that idea is a really good idea. It's a very ambitious kind of goal to do this. So I think it's going to take a little while to sort of work through the kinks and things like that. And as we were debugging, I think there were a lot of things we saw that we could have done a lot better here. I don't think it really swarmed over all the fields. And I think if I remember right, your swarming set was only 500 records or something like that.
So I ended up.
There's a lot more we can do to like really tweak this and make it better. But I think the core of it is really interesting, and it's sort of a base. Now you have all the codes in place and the framework. You can actually start experimenting with this a lot more.
I think
Yeah.
it works.
Yeah. Yeah.
It worked very well, but it takes a few. You gotta, work on it.
Yeah, and it might be that you need multiple CLAs working together to do a good job, because 1,000 features is too much for one spatial pooler to handle. So you'll want to group it together somehow. But those are all kind of tweaks that you can put in over time.
Again, I'm wondering about the sampling rate, because you're doing, 10 times a second, you said?
Right.
And I'm looking at these scenes now, they're not changing very much. So you'd have a lot of the same value over and over and over and over and over again. It doesn't make a great sequence. So I'm just wondering if was there any thought given to that?
It was basically as fast as I could get images out of this neural net.
Yeah, I think it's almost too fast, I'm saying. You can oversample, and so if you're feeding in a series of zeros or series of any particular number into CLA, and you're trying to learn the sequences of them, it's basically, I think it's a static variable. So I'm just curious, like right now, nothing's moving, so I see that values down there are both 0, I guess, or something like that. Anyway, that's something to think about too, because there's higher data isn't better. You want variability in the data. You can take any data stream, if you oversample it looks flat, and that's not good. So I don't know. It's something to think about. I'd go slower.
Thanks, Greg.
Yeah.
Thank you.